again. Yeah. So the problem was the cards, right? 3 cards without replacement, and the probability that all 3 of them are diamonds. Okay.
Right.
Well, first of all, do you know how deck of cards look like?
Yes.
Let me just. I forgot that I need to share my screen.
I have a sheet right here with all the with the sample space for the cards, a deck of cards and dice.
Okay, good. Yeah, I mean that actually would be very helpful. So, first of all, we know that we have 13 of each suit, right? So 13 diamonds, 13 hearts, right?
Yeah.
Etc. etc. Yeah.
Yeah.
Okay. So it's asking us to have 3 cards. So that's my first card. This is my second card. This is my third card, right? First, second, third.
Yes.
Okay. So I know that the probability of me choosing the first card to be a diamond is 13 divided by 52, right? Because there's 52 cards in total.
Uh-huh.
Yeah. The second one, remember, I did not replace my card, right? So it's not going to be 13 anymore because I took away 1 card, assuming it was a diamond, right? So it's going to be 12. But now also my sample space is going to change because I no longer have 52 cards in total. Now I only have 51.
Oh, okay.
Now the same thing is going to happen here. Assuming I already got one of my diamond ones, it's going to be just 11 diamond ones left.
Okay.
And here my sample space also changed because I'm not returning the cards into the deck. I'm just taking them and putting them on the side. So now it's going to be just 50.
Okay. Wow,
Yeah.
that makes sense.
So when they were asking you to, so what you're gonna have to put into the system or into the program or your homework, it's just gonna be, we're just gonna have to multiply them so that we have big numbers because they want fractions. They don't want a decimal.
Okay.
So fraction is gonna be 13 times 12. You just multiply the numerator and then you multiply the denominator.
Got it. Okay, let me go back.
Yeah, so it's gonna be 1716. And then it's going to be 52 times 51 times 50. It's going to be 132,600.
Okay.
Wow.
That makes a lot of sense.
Yeah, so that's how they want you to put it in because they don't want to see decimals.
Okay.
At least that's what it says.
And then do we simplify it? So this is the answer right here?
Well, I mean, I'm pretty sure it can be simplified. I just don't have my calculator or a good calculator right now. I think, I mean, at least it's divisible by 2, at least.
Yeah, no, for sure.
But like, there is a simplified form of it. I just don't currently have my calculator.
Oh, that's
anyway.
okay. I have a calculator. Don't worry about it.
Oh, thank you.
So it says right answer as a percent. Oh, okay. Maybe if you can help me with this too. It says right answer as a percent rounded to 1 decimal. So I'll put it in my calculator. And then if you can just explain like the rounding to 1 decimal, like sometimes it gets confusing.
Okay, yeah. Well, if you just put it into your calculator, it's gonna spit out a decimal point, right? I mean,
Right.
decimal number. So what was that decimal? It was
Point.
0.0.
Yeah. 0.012941.
Okay. Yeah.
1765.
1765. Okay, I mean, it's a big number. We really don't need all that because they said only one decimal point. However, they want it as a percent. This is not a percent.
Right.
This is just the proportion. This is just this on top over this would give you this number, right? It's just a proportion. If we want a percent out of a proportion, you have to multiply it by 100.
Oh, wow. Okay.
Yeah, so once you do that, you can just multiply this number by 100. You're going to get 1.29411,765.
Right.
Percent, right?
Mm-hmm.
But again, they only asked for one decimal place. 1 decimal. So let's look at this. My decimal is right here, and this is the first place right after it. So this is my 1 decimal. But we can't just write 1.2. We have to consider the number that's next to the 2. What is that number?
A 9. So would it be 1.3?
Exactly. So I mean, wait, sorry. Yeah, you're right. So it's gonna be 1.3. 1.3. So it's 1.3%. approximately.
So, is that gonna be like something I can use all the time? Like if it asks for a percentage, I just multiply by 100, the decimal?
Yes, if you have a proportion and they ask you for that percentage of that proportion, then you just multiply by 100.
Wow, that's very helpful.
Yeah.
Okay, great. Okay, maybe if let me see if I can go back to my homework.
Yeah, I'm gonna stop sharing my screen. Would you mind sharing it with me?
Yeah, no problem.
Yeah.
Let me see. So this. Okay,
So
so find the probability that all three cards are diamonds. So the probability that all three cards are diamonds.
Mhm.
And then the answer was 1,716.
Yeah, I'm gonna see if I can actually simplify that fraction, just because, like, I mean, I know what is it called? I know it's simplified. It can be simplified, but I just don't know the simplified version of it. It's 1716, right?
Yes.
Divided by 132,600. 132. Oh, sorry, 132,600. I'm just gonna see. Yeah, it actually simplifies to 11 over 850.
Oh, okay, nice. Yeah, I noticed right here though, it says right answer is a fraction, not
Oh, no
simplified,
simplified. Oh,
and no
okay.
commas. No commas.
I guess. Okay, well, we're good.
Yeah, I didn't realize that till right now. I was thinking in my head, like, oh, maybe we have to
We should, yeah,
simplify.
that's what I thought too. Oh, well. Well, that's interesting, actually. Okay. By the way, the common factor, if you're wondering, is 156. They're both divisible by 156.
Oh, wow. Okay.
Yeah.
Thank you.
So is that likely to happen? It's unlikely, right?
Unlikely, right?
Mhm.
So less than 50%.
Mhm.
Okay, let me see. I'm going to enter to see if the system says it's correct. I know it is, but awesome.
Awesome.
Okay, so this one right here, find the probability that all three cards are not red.
Okay, so what does not red mean?
So that would be
These
like
cards.
all the black cards?
Exactly. Well, we know there are 13 cards of every single suit, right?
Yeah, right.
So how many black suits do we have?
Black suits would be 6.
Yes, exactly. We have we have 13 of each one, right? So
Yes.
you said 26, right?
Yes.
Yeah, 26, exactly, because 13 plus 13. Correct. So we have 26. However, again, we're not replacing them. So we're going to have to do what we were doing the first one. I'm going to share my screen again and we can do it again so that
Okay.
you can write it.
Do I need to stop sharing?
Oh, no, I think I can just start with, let's see.
So is
Yeah.
this this is the same thing. It says 3 cards are drawn from a deck without replacement. So it's the same
Mhm.
concept, but
Yeah, it's the same problem. Exactly.
okay.
Yes. They can change the problem, but for this one, they did not change it. So we said it's gonna be we have 26 black, right? 26 black cards. Okay. So the probability of me getting the first black card would be 26 over 52.
Got it. Okay. Oh, so it's pretty much the same. It'd be times 20,
Exactly. So do you want to tell me what's gonna be after?
25 over 51,
Exactly. And what is after that?
and then 24 over 50.
Perfect. You got it.
Oh,
So
great.
yeah, so now we still have to give them the unsimplified fraction. So do you want to tell me what the unsimplified fraction would be?
Yes, so that would be, let me put it in my calculator. 26 times 25 times 24 is 1,500, or yeah, 15,600.
Okay.
And then for the bottom part would be, oh shoot, sorry about that. 52 times 51 times 50 is 132,600.
Exactly. It's the same as this one, right? It's the same as the top one right here.
Right.
Yeah, because it's the same. Yeah, exactly. Perfect. You got it. So now we're gonna have to put that into your thing because it said not simplified. So yes.
So that would be dividing those two.
Here, I'll stop. You can share yours if you want.
Okay. And then I got, so 0.11. Oh, wait, so I could multiply that by 100 to get a percentage. And then it says 11.76. Right answer is a percent rounded one decimal place. So because there's a 6, it would become 11.8.
Let's see. Yes, 11.8. Perfect. You got it. Oh, you didn't put in the. That's okay.
Let me see.
But yes, you got everything.
3 cards are not, at least 3 cards. I think they made a typo right there, huh?
Exactly. You got it.
Okay.
Oh, wait, are not red? Like,
Yeah.
isn't it supposed to be RED?
Yeah, I think there's a typo. Let me double check. Because there's no other option that's similar.
Oh, okay. Yeah, that's okay.
Yeah, I think
Let's try it. If not, we'll fix it.
And then it was 15,600.
Over
132,600. Great. Awesome. Okay, this makes sense. This makes sense now.
That's good. Yeah. So let's do the last ones on this problem.
Okay.
I mean the last parts. Yeah. Perfect.
Okay. I won't submit it because I know that those are the answers. Okay, so then for here.
Okay.
Let's see, what are these? Find the probability that the first marble is red and the second marble is right. Oh yes, this one I definitely need help with.
Okay, sounds good. We can do that. Let's see. So it says a bag contains 9 marbles, not 9 red marbles, 8 white marbles, 6 blue, and randomly choose 2 marbles, one at a time without replacement. Okay, so we're just choosing any 2, again without replacement, right? So that means that our denominator and our numerator is going to change. So it says probability that the first one is red and the second one is white. So let's just, can you go back to the problem so I can take a picture of it, please?
Sorry.
No, that's okay. Thank you. Sorry, it's my fault.
I wasn't sure if you were like doing something.
Oh yeah, because you can't see me unless you go to my screen. Yeah, that's okay. So I'll just I'll go share my screen right now. Okay. I'll always tell you when I'm sharing my screen so that you can you can get notified.
Okay, thank you.
Okay. I'm gonna stop this recording for this one and then start another one for the next because it's not like a second problem now.
Okay.
And that's what I'm supposed to do, I guess. Here. So I'm gonna